Good morning. This is the video, first of several videos that I promised to make with regards to lessons 6.2 and 6.3, which will be included on our next exam scheduled for Wednesday. We'll start here with lesson 6.2, where we learn about the basics of quadratic equations. Our learning targets in lesson 6.2 are to be able to solve quadratic equations using factoring. That's going to be a review. We've done that previously. Second, to be able to solve quadratic equations in the form x squared equals a. And third, to be able to solve problems that pertain to right triangles and right triangles that have 30 and 60 degree angles in them. So first, what makes something a quadratic equation, as I mentioned in class yesterday, is that it's a second degree equation. So that means the highest exponent of any variable within that equation is 2. There is no exponent higher than that. So this would be an example of a quadratic equation because the highest exponent on the x is equal to 2. Or this would be an example of a quadratic equation because again you've got a y squared and you have a y. The highest of the two is the y squared, so it's degree 2. Or this would be an example of a quadratic equation because once again the highest degree of any variable is equal to 2. Now, a quadratic equation with a single variable x can be written in what's called standard form, and standard form just looks like this: a times x squared plus b times x plus c is equal to 0. We've seen that form before, and we've referred to it as standard form. So a and b and c are just real numbers. A can't equal 0 because if it did, you wouldn't have a degree 2 polynomial because you'd be multiplying 0 by x squared, which would in turn make the x squared go away, no longer degree 2. So as I mentioned, when the equation is in the form ax squared plus bx plus c equals 0, then that equation is known to be in standard form. And we've solved quadratic equations in the past by factoring. We find our factors and then we set each of them equal to 0 to find our solutions. Let's demonstrate that here. Example. So we're asking you to solve the equation 3n squared plus 14n minus 5 equals 0. And you can already see that that equation is in standard form. And so if we wanted to try to solve this by factoring, we'd want to find factors of negative 15, because 3 times 5 is, or negative 5 is negative 15, that add up to 14. Those would be negative 1 and positive 15. So we break down using the grouping method. We break down the 14n to, positive 15n minus 1n. Positive 15 times negative 1 is negative 15, and positive 15 plus negative 1 is positive 14. Then we bring down our 3n squared. This process should look familiar, and our negative 5. And now we continue to use our grouping method. The greatest common factor of the first group there would be 3n. That would leave us with n plus 5, excuse me. Now remember, in the grouping method, if you have an n plus 5 in the first group, then you're going to have an n plus 5 in the second, if it's factorable, and it is. So what did I pull out of these two terms here to be left with n plus 5? Well, I pulled out a negative 1. So once again, using my grouping method, The greatest common factor of those two groups is clearly n plus 5, so that's one of our factors. If we factor that n plus 5 out, we'd be left with 3n minus 1. So we have our two factors that multiplied together equal the original quadratic expression. Now we set each of them equal to 0 and solve for n. To solve n plus 5 equals 0, we have to subtract 5 from both sides, and we'd find one solution is negative 5. To solve the equation 3n minus 1 equals 0, we'd have to add 1 to both sides and then divide by 3. So we find that our solutions to this quadratic equation by factoring are negative 5 and positive 1/3.